what it is. It's a recap of in part A. We're going to recap from year 11. We have 2 take I is a factor of some cubic polynomial. We're just told P of X is a cube. We don't know anything else about it, but we do know that 2 take I is a factor. Okay? So if 2 take I is, that means 2 plus I is as well. Okay? We should remember that from complex numbers. 2 take I and 2 plus I. And these are imaginary roots, but we can use them to give us a real quadratic factor. So the quadratic factor of this cubic we get from the sum of the roots and the product of the roots. Okay? When we add these 2 roots together, we will get 4. And when we multiply them, if we go 2 take I times 2 plus I, difference of 2 squares, it's going to be 2 squared take I squared. Alright, which is going to be 4 take square root of minus 1 squared, so 4 take minus 1, 5. Okay? So product is just multiplying the roots together. So then the quadratic factor we get, remember, it's going to be a times take the sum of x plus the product. Okay, we don't know what this value is out the front, but that's what it's going to be. So we're just going to input these numbers in for this quadratic factor. It's x squared, take 4x plus 5. Okay, so we've got most of the cubic. We also know that there has to be some linear factor. We don't know what it is, but there has to be some linear factor. So let's call this linear factor x take b. Alright, and I'm not going to put an a out the front because then it's just convoluting the amount of variables, okay? What we can do is we can call it x take b, and you can pull whatever that number is out the front. Okay, so that's a legitimate operation because we have the unknown out the front here. Alright, so that's our cubic. We've set up our cubic. And then we're told when p of x is divided by x take 1, the remainder is 6. And when p of x is divided by x take 2, the remainder is 5. So let's use the remainder theorem to solve these values for a and b. Alright, so we have p of 1 is going to equal 6. When I put 1, the number 1, where the x is, into this cubic equation, we're going to have a times 1 take b times 1 take 4 plus 5. That equals 6. Let's simplify this a bit. We'll have a take ab times 1 take 4 minus 3 plus 5, 2. So 2a take 2ab, 6. Alright, so we can see we're developing some simultaneous equations to solve the values of a and b. Alright, let's use the next piece of information, which is when it's divided by x take 2, the remainder is 5. So that means p of 2 equals 5. And let's go ahead and calculate that one. Alright, so substituting 2 into our cubic polynomial, and that's going to equal 5. So we'll have 2a, sorry, 2a minus 4 plus 5 times 1. Right, we've got 2a take ab is 5, and we've got 2a take 2ab is 6. Alright, because of this product here, we can't just put it straight into our calculator without substituting for another value, so let's not do that. Let's go ahead and solve this one via substitution. So the 2 equations we have, we've got 2a take 2ab equals 6, and we've got 2a take ab equals 5. Alright, so first let's use elimination actually, because we can see that they're going to cancel nicely. I'm going to do the top equation, take away the bottom equation. Top one, take away the bottom. So we've got 2a take a, that's take 2a, that part's going to cancel. And then I have minus 2ab plus ab, that's going to give me minus ab. And 6 take 5, 1. Cool. Alright, so we've got minus a is 1, and now we're going to substitute this piece of information into either of them. Doesn't matter which one we do. We'll go this one because then there's less multiplication involved. So we've got 2a, take 1 equals 5. Alright, so that's the equation. Remember that negative there, just because I took it away. Subtract it. So when we substitute a minus ab is 1 in, oh, hang on, it's going to be 2ab plus 1. Yep. So we've got 4. Okay. Alright, and then to find b, we can put it in any of the equations. We've got a is 2, so that means, let's put it in the second equation again. We've got 2 times 2, take 2b equals 5. And we can solve this for b. We'll have 4, take 2b is 5, we'll have minus 2b is 1, and b is minus half. Okay. All right. So this part here is the fundamental theorem of algebra. All right, finding the quadratic factor, and then we've got some application of the remainder theorem to generate our solution for a and b, and then we could find the quadratic in fully expanded form, etc. So it does say find p of x. Well, we've got a, we've got b. So p of x is what's a 2 and b is right, and that 2, remember I said we're leaving it out front, that 2 could distribute, and so you could have 2x take 1 as that factor there, okay, or we can have it written down. Alright, we will just get started on b, and it'll be one that we finish at home. So with b, we've got 1 plus 2i is a root, so that means the other root is 1 take 2i. Together they sum to 2, and the product will be 1 take minus 1 take, let's do it 2i squared, which is take 4 times minus 1, which is plus 4. The product is 5. Okay. So the quadratic factor we're getting from this one, we have 1 plus 2i and 1 take 2i. The quadratic factor is going to be x squared take 2x plus 5. Okay, and then we'll set them up, and I'll show you guys what we need to do for the rest of it. So we're going to have some polynomial. Let's write out what they've given us actually. We've got 2x to the 3, take 5x squared plus bx, take 5. Okay, that's the cubic. We know this quadratic is a factor. It's x squared take 2x plus 5. And so then we know we have to multiply it by a linear factor to get the cubic. And we know the linear factor, the leading coefficient, is going to need to be 2x. Alright? So that we can get x squared times 2x gives us the 2x to the 3. And then we'll just chuck on a letter that we haven't used yet, b. Alright, that's the linear factor. Sorry, b is involved. Let's use a. Alright, and we're just going to perform that expansion and equate the variables. Okay? Excellent. Again, like doing polynomials, we'll use synthetic division. That could be another procedure you use to solve. Alright, so let's wrap it up there. That's for 2G.